Today,
Good day.
very good, because we are getting some interesting stuff. Okay, we're going to cover, I guess you can call the entire thing conic sections, where we're going to look at parabolas, ellipse, and hyperbolas. Okay, but not just in the general idea, we're going to take really detailed looks at them. Okay. Okay, so first let's look at the parabola. Okay. We're going to look at the actual genuine idea, or really cutting down to it. So first we're going to start with that point, and I'll make it a little lower, and that line. Okay, so this point we're going to call that our focus. Actually, let me move that parabola up a little bit so it's not in the way. Okay, and this line here, we're going to call this our directrix. Okay, so what if we find a point halfway between the focus and the directrix? So we'll make that point there. Okay, so let's say we go to the left and to the right, and we find every point that's halfway between the two. So let's say we go from here to here, where this point shows us that the distance from the focus here and and this point to the directrix are the same. Let's say we do the same thing. So we find a point here, where the distance between the focus and the directrix are exactly the same. Okay, so let's say if we find some point here and do the exact same thing, where the distance from the focus to that point and the directrix to that point is exactly the same. And we go the exact same way in the other direction. And let's say we go from that direction to that direction, and keeps on going and going and going. Okay, so if we connect all of those points that are the same distance between the directrix and the focus, it would actually give us our parabola. So it kind of looks like a little spider web thrown out there. Okay, I'll leave that up for a few seconds. Right. So let's say if we draw our parabola, where this is our vertical, and move that down a little bit. There we go. And draw a little boundary line where this parabola is our horizontal. Okay. So we know right from this previous page, the point just below the focus is our vertex. Okay, so we know that this is our vertex. Okay, so that means our focus would have to be up there. Okay. And it's the exact same thing for a horizontal parabola. That's your vertex right there. And your focus would be right there. Okay, now your vertex, we're going to make that our HK. And same thing here, we're going to make that HK. Okay. Now if you have a vertical parabola, your general formula for that, oh, forgot to give you P. The distance between the focus and the vertex, we'll give that the value P. Same thing here. So if P is positive, you know it opens upward. And if P is negative, you know it opens downward. But if you have a horizontal one, it's a little bit different, but not much. If P is positive for a horizontal, it opens up to the right. And if P is negative, it opens up to the left. Okay, now we actually have a great big long detailed explanation that's about 5 pages long as to where the formula came from, but those will be attached to the scan note, but you don't have to know them, so that's why we're not going over them. But the general formulas for vertical parabola is x minus h squared equals 4p times y minus k. Now for horizontal, the x and y terms kind of switch. So our general form, well, general formula, forgot the A, for our horizontal parabola is y minus k squared equals 4p times x minus h. Okay. Now if you remember back to this one, just a quick time, you notice you also had a directrix here. So for our parabola, we're going to have our directrix. For horizontal, your directrix will be vertical. So we're going to look at the formulas to actually find your focus and your directrix if they ask. Okay. So we have our general formula, which you're going to need to know. Now your focus is going to equal whatever your x value is for your vertex, so it'll be h. Remember, that's just your hk. And that'll be k plus p. So if you're starting here at hk, your focus is going to be at that same x value. You're just going to go up p number of units. That's why that's k plus p. Okay. Now your focus, when it's a horizontal, is now your x value would change. So that'll be x plus p comma k. Okay. Now if you were looking for your directrix, okay, remember when you have a vertical parabola, your directrix is just going to go left to right. It's going to be y equals something, because that's just a straight line. Okay, so if you have your directrix, that's going to be y equals whatever your k is minus p. Because remember, your focus, your vertex is right between the halfway point between your focus and your directrix. So that vertex is right in the middle of them. So if you start at your vertex, move that down a little, and you go up p units, you're at your focus. But if you go down p number of units, you're at your directrix. Does that make sense? All right. Okay, so we know that p is equal to the sine distance from vertex to center, or you can say from the directrix to vertex. Or vertex to directrix. Okay, so mainly you need to know those three things. I mean, you need to memorize those three, but you want to definitely know that. Okay, so it'll be the same thing with our horizontal. But for this one, our directrix, you notice that's a vertical line. So that's going to be x equals something. Okay, let me move that down just a bit. So if we know this is going to be x equals something for our vertical line, we know that this point on the directrix is the same distance from the vertex as the focus is. So the directrix is just going to be x equals h minus p. So you have your h plus p for your focus and h minus p for your directrix. Okay, so we know that, again, the p-value is the same for both of them. And just to write it down, your vertex is hk for both. Okay, I'll leave that up for a few more seconds. right, so let's say, for example, we want to know what is the standard form of the equation of the parabola with the focus -1, -10, and the directrix y equals 4. Okay, so they gave us those two things, and they want us to find the overall formula. Oops. Okay, so the first thing you're going to look at is the fact that they gave you the directrix. Okay, the directrix is y equals 4. So you already know that when it's a vertical parabola, your directrix is y equals something. When it's a horizontal parabola, your directrix is x equals something. So the fact that they gave you y equals 4 lets you know it's vertical. Since the directrix is, let's say, y equals d. D is just some number. In the form of that, we know it opens vertically. Okay, so just the fact that we know it opens vertically, we know where to start. We know it's x minus h squared equals 4p times y minus k. So we know out of the two formulas, we know exactly where to start. Okay, so the first place we're going to look is to solve for our h and our k. That's our vertex. Okay, so we know the vertex is midway between the focus and the directrix. Okay, so usually at this point, it helps to graph those 2 points just to visualize it. So give it a graph of the points. Okay, it doesn't have to be specific, you just want to be able to visualize it. Okay, so if we have our x and y axis here, so that's our x and that's our y. Okay, we know our focus is -1, -10. So let's say this is -1, -10. And like I said, it doesn't have to be all that precise. You just want to point it out. -1, -10. Okay, and we know our directrix is y equals 4. So let's just say this is y equals 4. Okay, so that means if this is -1, -10, at some point on our directrix, we're going to have a -1, 4. Okay, so just one right above the other. Okay. So since we already know that the vertex is halfway between the directrix and the focus, we can actually just use the midpoint formula to find our vertex. Okay. Using the midpoint formula, and we're actually going to use it on those 2 points. Okay, so we know negative 1, 4 and negative 1, 10. We can make those our x1, y1, and our x2, y2. Kind of draw a little arrow up there. Okay, so we have our x1, y1, and our x2, y2. Okay, so our midpoint formula in this case will actually give us our vertex. Okay, so remember that's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Okay, so that's your midpoint formula. Okay, so if we plug everything in, our x1, x2 is negative 1 plus negative 1. So we have negative 1 plus negative 1 divided by 2. And your y1 plus y2 is 4 plus 10. Well, that should be negative 10. Sorry about that. Okay, so that should be 4 plus negative 10. Let me put them in the right spots. 4 plus negative 10 over 2. Okay. So if we have negative 1 plus negative 1, that's negative 2 over 2, which is negative 1. So we have negative 1. And 4 plus negative 10 is negative 6. Negative 6 divided by 2 is negative 3. Okay. So this is actually our vertex, where we know that our vertex is h equals negative 1, and our k is equal to negative 3. All right, does that make sense? All right. Okay, how does this keep breaking off? Come on, there we go. Okay, so now we found our h and our k. Now we have to find our p. Okay. So we know that p is equal to the distance from the vertex of the focus. Or the directrix of the focus, whichever one you wanted to use. Same general idea. So that means P will have to equal, because remember, you're looking for a y value. So that's the distance between y equals negative 10 and y equals, where's our vertex? Negative 3. Okay. So once we find that distance, we'll have our p value. That means p is equal to y equals negative 10 minus negative 3. Remember, whenever you're talking about difference, you're looking at subtraction. So that's going to be p equals negative 7. Okay, so we have our h, we have our k, and we have our p. Okay. So once you have all three of those, you just plug them right into your formula. Okay, so we know that x minus h squared equals 4p y minus k. If we plug in everything, that's going to give us x minus, our h is negative 1, so that's going to be minus negative 1, so it's plus 1. Squared equals 4 times p, or 4 times negative 7, times y minus k. Actually, I'll just leave that as negative 3 since I have to rewrite it anyway. And instead of plus 1, I'll just keep that as minus negative. So minus negative 1. Okay, so if we go ahead and just simplify everything, we have our general formula of x plus 1 squared equals negative 28 times y plus 3. All right, so any questions on that one? I know it's a lot to remember, but do the overall steps by themselves make sense? Okay. All right, so if you did want to graph it, you know, your vertex is at -1, -3, which would be about -1, -3. Yeah, I'll say it's about right here. And we know it opens downward, so it would look like that because our 4p is negative, or our p is negative. So since you know our p is negative, it opens downward. So it would look something like that. All right, leave that up for a few more seconds. Excuse me. All right, so let's say for our next example, what is the standard form of the parabola with a focus at the point 5, -1 and directrix of x equals -9? Okay. So for the last example, if you remember, the first thing we looked at was the fact that our directrix was y equals 4. That let us know that it opened up vertically. Now, if you look at this directrix, it's x equals -9.